next stage is prototype development. So just recall the first picture that I showed you. So I'm going in the same step by step. So till previous stage, layout design, everything was on paper or on software tools. So if you recall, when we started with product definition and architecture, we used maybe a pen and paper, or we use some Word document or a PowerPoint or Excel sheet to write things. Then after that, in the schematics, placement and layout design, we used some software tools to do that. Now it is time to build a physical product that meets most of the specifications. I'm saying most because not all the specifications can be met, because we are still in the prototype stage. The product at this stage is not production ready. So what is the meaning of production ready? That means I can't build hundreds or not even hundreds, sorry, thousands or lakhs or millions of this product. So it is a product which will meet some specifications, but it is not production ready. You can't give this product to your customer. Your customer will not like it because it will also not look like a real product. Okay, it does not have the look and feel of a real product. It also does not meet all the specifications. So that's why it is called as not yet production ready. So what are the various steps? So again, I'm simplifying here and putting very like 2 or 3 steps here. So first thing is, once you have completed your layout, you send that layout file, because it's a software. So you take the layout file from that software and send it to a factory to build the PCB. So you have done the placement, you have done the routing. So now you send it to the factory and they will exactly implement based on the file that you have sent. It's a software file that you send, like a Gerber file is what we call. So once you do that, you assemble the components. So if you remember in the schematics section, so we had created a table. We had created a table saying that I have all these components that I need. I need these resistors, I need these inductors, I need in 100 quantity and all that, right? So now you know that this is the quantity you require. So you have built the PCB, you know what components are required. You have to put them on the PCB. Assembling means taking the components and putting it on the PCB. So obviously it's an automated process. There are machines to do that. Normally in complex designs, human beings don't sit and do this work. So there are machines which do this work. So once this is done, your factory typically does a quick test, a visual check and electrical check if you ask them to do it. Okay, so they look at for visual defects, if there is any damage in the PCB or damage in the components, right? You don't want that PCB to be sent it to you. They may replace that part, or they may replace that PCB and send you a working one. Then they'll do some quick electrical check to see that, okay, there is no short or anything between power supply and ground and all that. Some very basic check. So I took this picture from Qualcomm website. So if you see here, this is their 5G millimeter wave phone prototype. So this is a prototype phone, 5G phone. So if you look at this phone, it does not even look like a phone, right? So if this is the phone, you would not even buy it because you cannot keep it in a pocket. So at least this part looks like a phone, but what is this, right? It does not even look like a phone. It looks very ugly. So I can't keep this in my pocket and say that I have a Qualcomm 5G phone. So prototypes are like this. They look like this because they are designed for a different purpose. They're not designed to be sold to customers. So I'm sure you've heard of POC. What is the full form of POC? Anyone who have heard of POC in this context? Yes, proof of concept, correct. So there is slight difference between proof of concept and prototype that I have put here. So what happens in a proof of concept is you really are not using the real components to build a system. You're just putting together some things to show or to prove your idea. So in proof of concept, what happens is, let's say I want to prove that something, I have an idea in my mind. I want to tell to the, show it to someone saying that, hey, I have an idea. I can show you this idea works. So what you do is you don't worry about what is the real components that you want to use. You may use some components which does the job and you'll prove the concept. Hence it's called as proof of concept. Okay, it's not a real prototype. So the prototype is a system which is using your real components. So if I want to use this microcontroller, if I want to use this particular resistor value, I use exactly those values, that microcontroller, that USB port, that display, so that it is as close to as my final design. Okay, that's the whole idea of building a prototype. So that's why you do a proper schematics, proper layout, and try to build a almost a close to a real system as possible. So it is hard to build a POC. So we directly go to a prototype design. So it's important that you build a good prototype so that you can prove your theory. So you've done hard work in coming up with a proper system architecture. You've done some modeling, simulation. You've done a good job in schematics, layout, placement, all that. So if you've done all the good job there, then your prototype should work as you expect it to work. Please subscribe to our channel by clicking on the subscribe button below to get regular updates of video releases.